In this question, we are given two particles, particle P and particle Q, and both of them, one moves along the x-axis and another one moves along y-axis. In such a way, both depend on time. Particle P, we are given the position x, a function of t equals 6 minus 4 times e to the negative t, and then for particle Q, we are given its velocity by the function v of t equals 1 over t squared. And we are also given that the position of the particle q at time equals 1 equals 2. And in the first question, we need to find the velocity of particle p at time t. And so recall that the velocity of a particle is equal to the derivative of the position with respect to time. And so we need to differentiate this. It's equal to derivative of 6 is 0, 0 minus 4 e to the negative t times negative 1. By chain rule here, this is equal to 4 e to the negative t. Let's move on to question B. In this question, we need to find the acceleration a of t for the particle q, and then we need to find all times t greater than 0 when the speed of the particle u is decreasing. So note it's the speed, not the velocity. And in this case, as a general case, a of t is equal to just the derivative v of t with respect to time. And we are given the velocity here, so it's a derivative v over dt of the 1 over t squared, which is equal to negative 2 over t cubed. So acceleration is negative 2 divided by t cubed. And note that acceleration is less than 0 for all t greater than 0. And note that v of t is positive for all t greater than 0. When you plug in any t greater than 0 in either of the two functions, you get this result here and this result here. And because speed and acceleration move in different directions, it means that actually for all t greater than 0, the speed is decreasing. If they were of the same sign, then in that case the speed would be increasing. But here the signs are different for all t. That's why it's decreasing. Let's move on to question C. In this question, we need to find the position of particle q at time t. And so let's recall the fundamental theorem of calculus, which says that the function f at point B minus f of a is equal to the integral from a to b of the derivative of the function. So in our case, y of the particle q at time t minus y, and we have the information about the position of the particle at time t equals 1. So y at time 1 is equal to the integral from 1 to t v of s ds for the particle q. And we can plug in the values here. So y u of t minus 2 equals integral from 1 to t of 1 over s squared ds. And this integral is equal to negative 1 over s at points 1 and 2. Plugging in these values give us negative 1 over t plus 1. So solving this further, y, basically adding 2 to both sides, gives us y position of the particle at time t equals 3 minus 1 over t. Let's move on to the last part of this question. In this question, we are being asked, as t goes to infinity, which particle will eventually be farther from the origin? And so what we really need to find is we need to find the position of the particles at as t goes to infinity. So we need to find the limit as t goes to infinity of x of p of t and limit as t goes to infinity of y of q of t, and compare those, which one is going to be greater. So limit as t goes to infinity of x of p is 6 minus 4 e to the negative t. And this is equal to 6 because the limit of negative 4 e to the negative t, basically goes to 0. So this is equal to 6, and then limit of as t goes to infinity of, we just found 3 minus 1 over t. 1 over t goes to 0 as well, so it goes to 3. So we can see that x of p is going to be farther from the origin. So the particle p, x of p of as t goes to infinity is greater than y of q as t goes to infinity. So particle p will be farther. Thank you for watching. If you find this video, please don't forget to click the like button, write me a comment below, and also subscribe to my channel where you can find more solutions to the AP Calculus AB and AP Calculus BC problems. And I will see you in the next video.